All right, guys. So today we're going to be talking about asynchronous JavaScript, and more specifically, we're going to be talking about promises, which is, I guess, a concept or a type in JavaScript. Also, be giving an introduction to HTTP. Again, this is a protocol that's used for web communication. And then we're also going to introduce the fetch API in JavaScript. Again, this is a pretty simple API just to kind of interact with the web through your JavaScript code. All right, so let's begin. Just go overview, again, kind of went over this already. First thing we're going to talk about is asynchronous JavaScript. So kind of talk about what asynchronous actually means and kind of how it's employed in JavaScript. Then we're going to be talking about JavaScript promises. This is a way to use asynchronous code a little more elegantly. It's not required that you use promises, but that's kind of like the new way of doing things asynchronously in JavaScript. Also, as mentioned, just a brief introduction to HTTP. Again, a protocol used for web communication. Just give you guys an introduction there. It's going to be beneficial, I think, for one of the challenges tonight, which is going to be starting an HTTP server. So we give an intro to that. And then finally, we're going to wrap up the lecture by talking about the fetch API. Again, this is just a simple method that you can use in JavaScript to kind of make HTTP requests from within your code. All right, so that's our overview. Again, a fair amount of topics to go through, so let's get started with it. The first topic is asynchronous JavaScript. So to begin, let's just give a definition of what synchronous means. So this is a dictionary definition that means existing or occurring at the same time. So this is a little problematic for me, maybe because I maybe don't fully understand the definition versus synchronous code. But when we actually talk about what does it mean to have synchronous code, this actually means that code statements in your application are completed in order. So the definition of synchronous kind of says exactly at the same time. However, when we talk about synchronous code, it actually means, not everything's being done at the same time, right? You're doing line by line execution. So first you do like statement one, and then once that statement completes, you do the next statement in your code. All right, so synchronous code is not exactly at the same moment where everything's being done. If you have your audio on, make sure you're muted. Just want to mention that.
Greg, do you want to mute, please?
So when we talk about asynchronous code, that's when we actually get to statements that aren't always completed in the way that they're lined up. So you might have statement A, B, C, and D. With asynchronous code, line C may complete before line B even completes fully. So that's where asynchronous code kind of, again, it's kind of confusing for me, where like the definition of synchronous means exactly at the same time. And that's kind of more tailored towards asynchronous code, where stuff can happen, I guess, kind of in parallel. So that to me would kind of be the definition of synchronous. But in this case, synchronous code means stuff is done in order, as in one thing waits on the other thing to complete. So it's actually called blocking code. So again, if you have statements A, B, D, and C, A will complete fully before B even starts to complete. Whereas in asynchronous code, you kind of have A running, and if A doesn't even complete, you could have B kind of started already. So that's kind of a methodology into having an application that can do multiple things at once. All right, so that's what asynchronous code is. Basically, you'd have multiple things going on at the same time, and there's no guarantee of completion order. All right, so again, we kind of talked about this. Synchronous code statements will wait for the previous statement to fully complete. So again, this is the idea of blocking. So one statement needs to finish what it's doing before the next statement can kind of approach what it's doing. The benefit of asynchronous code is that statements don't need to necessarily wait on the previous statement. And this is sensible for where, like, again, if we have statements A and B, just keeping it generic, if what B needs to do does not rely on what A needs to do. Like, for example, let's say A is printing out a line to the, like a statement to the terminal, and then B actually wants to compute a value. Those things are unrelated. So B doesn't actually need to wait for line A, which is printing out to the terminal, to actually complete, right? B can actually start its calculations theoretically because it doesn't rely on anything before it. So that's where asynchronous code might make sense. And if you think about it, that's going to be faster execution usually, because since things are being done independently, you're saving time because the time's kind of overlapped. Does that kind of make sense? Yeah, let's actually just do a simple example, and then we could maybe understand what I'm trying to convey here. So I'm actually going to just do some tasks in front of you. Hopefully they won't take too long. but I have a task list here. So here's my task. I'm going to do this synchronously. All right. So my first task is, what is the distance between Tokyo and Chicago? I actually don't know this, so I'm actually going to look this up. So let's go to my browser and close this window. All right, let's actually just type in Google. Hopefully Google can tell me. So what is the distance between Tokyo and Chicago? Without typo, hopefully. All right, so I got my distance. So my answer is 10,129 kilometers. So that sounds pretty far. I've actually never been to Japan. Maybe one day I'll go, but that'll be a decent flight to get there. All right, so that's task one. Let me do my next task. All right, what is the capital of Turkmenistan? Again, this is something I have not looked up before, so I'm actually going to learn on the spot. Let's see if Google knows. What is the capital of Turkmenistan? All right, awesome. Google gives me a good response. So it's a city called Ashgabat. Hopefully I pronounced that correctly. If not, I apologize. But all right, cool. I kind of learned something today. Turkmenistan, it's located somewhere in Asia. I know that, so let me actually zoom out. All right, so Turkmenistan, Central Asia maybe, but cool, kind of learning some facts here. All right, so that was task two. Last task. What is the population of kangaroos in Australia? And again, this is something I've not Googled before, so I'm actually gonna learn what this answer is. I'll go back to my Google, and what is the population of kangaroos? This might be a little tougher question to answer, but maybe Google is smart enough. All right, so they have estimates. So it seems like there's two main types. There's red and gray kangaroos. I didn't quite know that distinction, but all right, so there's approximately 11.5 million red kangaroos and over 16 million gray kangaroos in Australia. So if I kind of add that up together, that'd be what, 27.5 million kangaroos in Australia. That's actually much higher than I would have guessed. I don't know if you guys would have guessed that high either, but yeah, okay, so that's a lot of kangaroos. I've actually never been to Australia either. I don't know if any of you guys have been to Australia. I think kangaroos are cool, but honestly, I get freaked out by giant insects, so I don't know if I could ever visit Australia and survive, because I know they have like giant spiders there, flying insects all everywhere. Might be better in the cities. Again, maybe I'm generalizing.
I'm sorry, no, yeah, there's only one location like that. It's a specified location. You have to go like a tour with like a tour guide and stuff.
Okay.
But everything else in Australia is not that bad.
Gotcha. Yeah, so it might be a fun trip to make, but have not made it to that side of the world. Yeah, but okay, so that's a lot of kangaroos. So that was my task list. Again, some random tasks, kind of learn some facts. So hopefully you guys learned some facts with me. But that was done synchronously. So I did step one first, which was find a distance. And I researched that, got an answer. Once I completed that, I moved on to my next step, which was capital of Turkmenistan. I already forgot the answer, but I could always look it up again. And then after I completed that, I moved on to my next step. So again, that was synchronously. I had 3 tasks to do. Did one, completed that, did the next one, completed that, did the next one, completed that. So it took, maybe a fair amount of time. I don't know how long it took, maybe a couple minutes, but that was synchronously. So let's actually try something else. So I'm actually going to ask for some volunteers here. So again, don't worry, it's not going to be a challenging problem, but can I get a couple volunteers? Or maybe I'll just pick someone out of the crowd.
Do it.
Who was that, sir?
It's Kyle Stiff.
All right, Kyle Stiff, and who else?
I'll do it. Wilson.
All right, we got Brian Jensen and Kyle Stiff. Thank you for volunteering. So we're gonna I have some tasks to do, but you guys are gonna kind of assist me here. So we're gonna do something asynchronously. All right. So we're gonna do this based on some of my interests. So I actually know the answer to the first 2 of these, but Kyle Stiff, I'm gonna give you a task, and then when I give you the task, you can proceed to look up, use Google or whatever you need to look up the answer. And then once you have an answer, just kind of let me know. You don't have to, don't actually tell me the answer, but just say, hey, I got the answer. And then we could check what the answer is when I get a chance. All right.
Okay.
So Kyle Stiff, your task. This is very specific to my interests. In episode 4 of season 3 on the show Friends, again, I don't know if you're a Friends watcher, I have a very specific question for you to research. So my question is, what food item did Chandler pretend to be buying for a fake party when he was talking to his girlfriend Janice at the grocery store? So again, this is episode 4, season 3, and he buys a very specific food item that's not usually bought for parties. And I kind of want you to kind of search and see if you can find that answer. All right, Brian, if I could give you another task. So in episode 24 of season 7 of the show Seinfeld, I want to know what was the cause of death for George's fiancee, Susan, as in how did she actually wind up dying?
Okay.
Right. So again, I don't know if you're a Seinfeld watcher, you might know the answer offhand, but if you kind of research that. Meanwhile, I'm going to do my task. So I have a task also. How many episodes of The Office are there in total? Again, my task is a little simpler, so I'm actually going to go about doing that. So Kyle, work on the first question. Brian, if you can try to research the second one, and I'm going to do the third one here. So I think, again, my task is a little easier. So I'm going to say how many total Office episodes. All right, Google seems to know that. I had a typo, but looks like there's 201, just over 200. So, all right, I've completed my task. So, that didn't take too long, but Kyle and Brian are probably working on their tasks. And notice that their tasks definitely take longer. Like I know that I gave them longer tasks. Let's see if they can come up with an answer shortly. Sorry, I don't know if this is too specific question.
Got the answer.
I can. You said what food item did he order?
Yeah. If you search for like episode 4, season 3 transcripts, you could probably search for something. Again, it might be a little harder. I think I gave Kyle the hardest one. But Brian, you said you have the answer. Could I get an answer from you?
Actually, so I found the answer on Google, and then I actually remembered the episode that it happened because I watched it.
All right,
she died from toxic glue from licking, or glue from licking the wedding invitations.
Yep.
Repeatedly.
Awesome. All right, cool. So yeah, Brian looked that up and he got us an answer. So yep, that's correct. Again, for you, those of you who don't watch the show, George was engaged to Susan. He wasn't thrilled about it, but he was going along with it. He's very frugal, so he bought some really, really, really cheap wedding invitations, and Susan was licking the envelopes to send those invitations out, and she wound up getting poisoned due to the toxic glue, and then she passed away, unfortunately. So yep, that's the answer to that. So thank you, Brian, for that. Kyle, I don't know if you came up with an answer, but my question might have been a little too specific.
Yeah, I'm still looking.
That's fine. Let's just assume Kyle finds the answer. So I don't want to take up too much time, but thanks for looking, Kyle. So the answer here for this silly question is actually Chandler pretended to be buying barley because that was the first item he saw. Backstory of that is he and his girlfriend had a little fight, and he was told that he should accidentally run into her on purpose. So he goes to a grocery store where he doesn't normally shop, but where his girlfriend shops, and he's kind of pretending to be there and like actually buying something, but he was trying to meet her there. Anyway, so a couple shows that I'm really fond of, Friends and Seinfeld, and Office also, great show. All right, so again, the main point here was this was kind of done asynchronously. I had my volunteer workers, so think again, Kyle and Brian, and they kind of handled these tasks for me. So if you notice, the first task definitely was a time incentives task. Likewise, the second one took Brian a fair amount of time also. So the advantage of this was that Kyle was able to kind of do his research at the same time that Brian was doing his research, and at the same time I was doing my task or my research. So this actually saves time because these are time incentives, so both those are being done in parallel. So at the very end, it's going to take a short amount of time rather than if I had to do all three of these in order, where if I had to actually Google this and if I didn't know the answer, I'd Google and probably take me it might take me 30 seconds, a minute to kind of find the answer, and then maybe another minute for this one, and then maybe 15 seconds for the last task. So if I add all those up, that's like 2.5 minutes maybe to do all three of these tasks. Versus if I can separate it out into different like workers, the job can be done concurrently, and then once they have an answer, they can just ping me and say, hey, I have an answer, and then I could kind of consume that answer, and then that saves time overall because like total, like maybe that'll take a minute 30 with everyone doing their tasks concurrently. Again, kind of simple example, but kind of just highlight why asynchronous code kind of matters and kind of why it's can be more efficient and faster depending on what your tasks are. Again, these three tasks are totally independent, so I can do them asynchronously. However, if I had tasks that did rely on the previous result, for example, if I needed to know the answer to this friend's question for some reason to know the answer for the Seinfeld questions, well, then I can't necessarily do them in parallel, right? Because one depends on the other, so one has to be done after the other task. All right, so that was just our silly example for asynchronous code. Let's actually get a little more technical. So talking about JavaScript in specific, JavaScript is actually a single-threaded coding language. So what does this mean? So threads, in a computer sense, are just those available workers that you have. So there are some languages like C++ that could be multi-threaded, and this just means that you could actually assign different parts of your application or your algorithm to different worker threads. And those threads can kind of go off on their own, do the work that's needed, and kind of return when they're done doing their task. And this is kind of what we simulated with our trivia questions from earlier, right? So JavaScript, on the other hand, is only single threaded. This effectively means that JavaScript can only do one thing at a time, and that's the synchronous model that we talked about. So again, if I needed to look up, kangaroos in Australia or, capital of Turkmenistan, I can only do that in order. I can't really have these additional workers per se, the way JavaScript is natively created. Again, that's single threaded, meaning JavaScript can only handle one task at one time. All right, but then there's a concept of asynchronously doing stuff in JavaScript. And so this is where we introduce the notion of asynchronous callback functions. And this is the idea of we can actually still give work to be done somewhere else. Again, normally when we're using JavaScript, we're using the web. And the web obviously is just an interconnected pool of data, like interconnected web of data, I guess. And so like if I need to extract information like from the Friends database, I can kind of send a request to the Friends database, and the database will do the work for me. Like it'll do the query. I'll send a query like, hey, what did Chandler buy, episode, whatever, at the store. And if this database has some API where I could actually query that, I could just say, hey, I need this answer, push it off to the database, and the database will actually do the work and then send me a result when it's ready. So I'm not actually going through that database myself because one, I don't have access to the Friends database. That's something separate, maybe on the web or wherever it might be. But yeah, I could kind of just send out that request, and then that request can come back to me once it's ready. And then JavaScript can kind of take that, take the callback and kind of do whatever it needs to do with the answer or with the task that was completed. All right, so there's a lot of words we threw in there. Let's actually see an example to kind of get through this. So I'm going to proceed. Let's talk about the key components of an asynchronous callback. So we have the execution. This is where we actually start the task that we need to do, the preliminary task. So in this case, in our example, like where I asked Kyle to look up the Friends trivia question, that was a preliminary task. All right. Once he he got started on that, we continue with our application. But then there was a callback. So I guess this wasn't quite clear in our example there, but the callback was basically when Kyle or Brian said, hey, I have an answer. And then here's what you could do with the answer. So for example, Brian's answer was, Susan died from licking toxic glue on envelopes. Once I have that information, if I actually want to do something with that, that's what the callback will be responsible for. So for example, if I want to just print that statement out to the console, that's what the callback logic might be. Or if I want to do something more advanced with it, like the callback is just like a function that will have logic in it that will be executed once a preliminary task for this asynchronous call is done. All right, and then some more technical pieces. We have an event queue. This is a queue. So we talked about queues maybe a couple weeks ago, but a queue is just basically first in, first out. So let's say, Brian got back to me and said, hey, I have an answer. And then Kyle, maybe a few moments later, says, hey, I have an answer also. They're going to be queued up. So Brian's going to be first in that queue, and then Kyle's response will be second in that queue. And so that's what the event queue is kind of responsible for. It's going to queue up the responses from asynchronous calls and then have that available to us when we're ready for them. Again, maybe I was still doing my research on the office and Brian said, hey, I have an answer. I might still be busy. So I might be like, hey, Brian, I'm still doing my work. I will take your response when I'm ready. So that's kind of what the event queue is responsible for. Then we have this concept of event loop. So event loop is kind of just, I kind of describe it as maybe like a, maybe a little annoying or a nagging toddler that's always kind of asking a question like, hey, can we do this now? Hey, can we do this now? Hey, can we do this now? So event loop is basically something that keeps checking if items from the event queue can be moved to the call stack. So the call stack is the final piece of this puzzle. We talked about the call stack, several times in past lectures. But again, just call stack is the active list of things that are being executed in your application. So the event loop kind of manages the event queue and pulls items off the queue when the call stack is ready to take new actions. All right, so a lot of terminology there. Let's actually see some visual example of this. So this is where I'm going to go to one of the coding examples that I have, but we're not going to be doing too much with it. So I want to introduce a method called setTimeout. This might be new to you guys, but setTimeout is just a handy function in JavaScript that can kind of simulate asynchronous events for you. It's not really, that useful in the sense of doing work for you, but it can simulate delays in your application. So the way set timeout works is it takes in two functions or two parameters. One is a callback function. Again, this is logic that I want to do eventually. And then you could pass in a delay in milliseconds. So this will specify how long like your simulated task might take. So like, for example, if I had a task of, checking out, finding the capital of Turkmenistan, I could estimate that would take 15 seconds. So like I might have a callback function that will handle the response, and the delay will be 15 seconds, so that in my application, that delay is kind of simulated. However, this will be asynchronous, so that 15 seconds will elapse somewhere else. It's not going to hold up my code because this is asynchronous. All right. And then here's an example of usage of set timeout. So I have a callback function. Again, I assign that to a variable called my callback. This is a fat arrow function. Again, get familiar with that notation if you're not familiar with it yet. So in this case, this function simply logs out the string world to my console. I'm going to use set timeout, so I pass my callback, and the 3000 is a timing value in milliseconds. So effectively, I'm going to wait 3 seconds, and then I'm going to execute my callback function. So in 3 seconds, once I call set timeout, I'll print out world to my console. So it's not going to happen immediately. It's going to be delayed for 3 seconds and then be printed out. All right, so again, that's the example of set timeout, which I'm going to be using in my code. All right, so let's actually get to a code block that I have. So let me pull that up on my screen. Again, if you want to follow along, feel free to. So I have this first block of code called async example. I'm going to uncomment that. Again, the shortcut for that is command / I could toggle it, so I could comment, uncomment. All right, so I have an async example using set timeout. Just going over this code, it's a few lines of code. I have a simple wait function. This is simulate blocking code. So this is actually going to halt my execution, and we'll talk about why I'm doing that shortly. And then my main program is basically printing out something to the console immediately. In this case, it's just the word blah, because I kind of ran out of the words to use. Then I have my callback, which we kind of saw in the slides, which simply prints out world. And then I have a timeout that is going to delay 3 seconds for that callback. Then here I have a wait of 8,000 milliseconds, so 8 seconds. Wait 8 seconds. So what this is actually going to do is actually going to block my code. So when I say block my code, is that it's not going to go to line 12 until line 11 completes. Because again, this is normal operation of JavaScript. It's synchronous by default, so one line has to complete before the next line can proceed. So in this case, I'm going to wait 8 seconds here. And then finally, after 8 seconds, I'm going to print out hello to the console. All right, so a few things going on here. We're going to talk about why I'm doing this and maybe try it a couple different ways. But let me move this down. Let me go back to my slides. All right, so this is my base simple program. All right. Any questions on this code? I just want to make sure if you're following along, it's going to make sense. All right. Hopefully that makes sense then. All right, so let's go back to all these colorful boxes that I have drawn up on my slide here. So I'm just going to talk about these windows. So I have my application. This is actually the code that I'm executing. So these 5 lines of code, again, printing out blah, having a callback, calling set timeout, waiting, and then printing out hello. Then I have something called Web API. This is something that your browser kind of has natively in it. This is some like magic, I would say, that it provides some functionality that you can rely on. So my application can actually take advantage of what my browser might be offering. Or in this case, I'm using Node. So Node has something very, very similar to this. So effectively, it's some magic that sits out there that I can kind of take advantage of. Also have the event queue. So we talked about this earlier. This will hold responses from asynchronous events. I have this event loop that kind of ties together the event queue and the call stack and basically pulls items off the queue when the call stack is ready for them. And then I have my output. So this is actually what my program is going to be outputting. All right, so a bunch of boxes. Hopefully the colors aren't too confusing. But all right, let's actually get started. So I'm going to start my application. The very first thing that happens, and this is going to be kind of hazy, so I apologize for that, but there's a concept of a global execution context for JavaScript. And I'm actually going to put that onto my call stack just to kind of make this a little more easier to understand. But basically, the event loop will start pulling things off the queue only when the call stack is empty and ready for new events. So if there's something already executing in the call stack, the event loop is going to be like, all right, you're busy right now. I'll come back later and try to pull off something from the queue later. So in this case, we have a global execution context that I'm going to just put on our call stack when our application starts. All right, so let's actually get into our code. So the red line is actually the point in my application where I'm at right now. So we're going to start at the first line. In this case, it's console.log. We're printing out blah. So let me proceed with that. So the first thing that happens is that our call stack gets that line of code. Again, this might be a function call, but in this case, it's just pretty straightforward console log. So the call stack gets that added. All right, the next thing is the call stack will execute that. So blah actually gets outputted to our console, right? So you see the output of blah, which is what we expected. All right, so we proceed to our next line. Next line is just very simple. We're just assigning a callback. So we're not really actually doing anything. We're just assigning a variable, creating a function, assigning that function to our variable called my callback. Again, you can name this whatever you want. Obviously, it's a variable, so name it accordingly as you see fit. But all right, so this line doesn't really do much. So let's go to the next line. Next line is set timeout. Again, this is the function we talked about. Set timeout actually gets pushed to the call stack, and then it's going to get executed. So again, the timeout is taking a callback and a delay. So this is actually where the web API comes into play. So set timeout interacts with the web API in that when the call stack executes it, it's actually going to move it to the web API arena. All right, so we're actually going to take it from the call stack and kind of push it off to this outside party. So this is kind of the notion. Again, when we're doing our example, like I pushed out some work to Brian. So Brian was doing some work for me while I could continue my my task list or my, I guess, application if I'm the application. So in this case, set timeout will be given to the web API and pulled off our call stack. So that's done. We've executed this line, but this work, there's still some work that needs to be done, but by someone else, not by us. All right. Then we go to our wait. So in this case, we're going to wait eight seconds. All right. But notice our timeout for our callback was 3 seconds. And there's a reason, that I chose a larger time. So our application is just going to be doing something for 8 seconds. It's actually blocked. It won't be able to get to the next line. So let's actually proceed in this example. So let's just imagine that 4 seconds have elapsed. I guess that should be 3 seconds, but so 3 seconds have elapsed. Set timeout will complete, as in it'll count, the three seconds, and then it'll push the callback to the event queue. So it did its task, and it's just saying, hey, here's your callback that you specified. So the callback gets added to the event queue. All right. The way web API is done with this job. Again, 3 seconds have elapsed. Our wait is still there because we're waiting 8 seconds here. So, we're halfway into that wait. Let's proceed. All right. So after 8 seconds, we finally completed that task in our application. All right. 8 seconds elapsed. And now we're on to this console.log. All right. So notice that we're going to print that. We're going to add that to the call stack, and then we print that. So we get our hello. And now we're actually done with our application. So I'm going to proceed to the next line, which is, we're done with the application. That global execution context kind of just disappears. Again, details on that I'm a little hazy on, so I'm not going to try to pretend I understand that fully. But now our call stack is fully empty, right? So this is where our annoying toddler comes into play. So this event loop is constantly checking. It's saying, hey, call stack, are you free? Hey, call stack, are you free? Hey, call stack, are you free? So finally, it gets an answer of yes. It looks at the call stack and say, hey, all right, you're not executing anything right now. Let me see if there's anything on the queue that you can do. So it's going to look on the queue and say, hey, there's actually this callback. Here's some work you can do. So the event loop is going to actually take that callback and push it to the call stack. All right. And that's, again, because the call stack is done. We've completed our application. So all of our synchronous tasks have been completed. Now the event loop kind of jumps in, and because that's something that I could add to our call stack. All right, so my callback gets added here. Call stack is going to execute it. And if we look at our callback, it's just a console.log of printing out world. So we execute that, and then there we go. World gets printed out. All right, so the whole reason I wanted to add this wait in was to kind of show that everything in your application completes before the event loop kind of starts pulling things off the queue. Notice that our event queue, our web API finished before our call stack finished. So we had our callback ready, even though our application was still waiting that 8 seconds, right? So we finish our application, and then the event loop starts pulling things off the queue. So that's why we get blah, hello, world, right? All right, so that was, again, a lot of boxes, a lot of arrows. Hopefully that was easy enough to follow along. But yeah, we have our application, we have a call stack we just talked about. We could push stuff off to the web API. In this case, that's what set timeout does. Again, the web API is just kind of a placeholder in that it could be something else. It could be like a database that you're contacting or something on the web. Like that's just magic, I would say. Some additional resource that you could push off work to. so that you can do stuff asynchronously in JavaScript. All right, let me pause there. Any questions about, the example we just went through? All right, so let's actually see how the code works here. Since I have the code up, I'm going to bring up my terminal here. Bring that up here. All right, so I'm actually going to execute this. So to do that, I'm going to do node async JS. All right, so notice we get blah printed out right away. Now we're waiting 8 seconds because that's what the wait on line 11 does. And then after 8 seconds, we get hello. And then notice that world immediately was printed right after hello because world was ready to go, but it was waiting on our application to finish. So blah came out immediately. Then we waited about 8 seconds for the hello to be printed out because we had that wait on line 11. And then once that was done, we printed out hello. And then immediately that loop was like, all right, hey, you're free now. Let me give you the work, which was printing out world. So again, if you saw that, blah was immediate, hello was delayed, and world was effectively immediately right after hello because world was ready to go. Let's actually remove that wait. So I'm going to comment out this wait. So now let's actually see how our application runs. So in this case, we're going to print out hello right away because it's just going line by line. There's nothing in between here that's going to delay it. So if I comment that out, clear my console, and this run. All right, notice we got blah immediately, hello immediately, and then we had to wait a few seconds before world came in. And again, that's because we had to wait 3 seconds for the web API to handle that. And then once it completed, we got the callback. And then once the callback said, hey, I have a result ready for you, that's when the event loop pushed it onto our call stack, and then we were able to actually execute that. All right, so just, again, this is kind of highlighting asynchronous code. Notice that even though our line 9 has the function, that's actually executed after line 12. So this is, again, breaking that synchronous execution. So we're not just doing A, B, C, and D. In this case, we're doing A, which is printing out something. B is going to be delayed. So then we proceed onto C, which is printing out hello. And then B eventually completes, and then we, add that execution. So, in this case, it's going A, which is blah, then C, which is hello, and then B, which is world. All right. I'm just going to pause a little bit in case there's any questions that creep up. But otherwise, I'm going to comment this code again and proceed. All right, no questions. All right, let's proceed. All right, so now that we completed a tutorial, I guess, or introduction on asynchronous JavaScript, kind of how it works behind the scenes, let's actually talk about promises. So in our previous example, we're using an asynchronous callback. That's kind of, I guess, the older way of doing handling asynchronous code. Promises are, I guess, a newer concept that kind of makes it a little more, I guess, consistent and maybe a little more feature-rich in terms of handling asynchronous events. So let's actually talk about promises. To begin, let me just poll the audience if anyone wants to kind of just shout out. How would you define a promise, just in plain English? Don't think about programming terms. What is a promise to you? So let's actually, let me just call on someone. Josh Franklin, you're first on my screen. So Josh, if you can just put in your own words, how would you define the concept of a promise?
I don't know. I've never really thought about that.
Sorry to put you on the spot.
It's like committing to doing something later.
Yep. Well, that's a great definition. Yep, I would totally agree. Yeah, so again, the concept of promise, pretty straightforward. We probably, are familiar with it in our daily lives. And again, it's not too different in a programming sense. So we're going to get into what promises actually do, but let's actually give our use case for using promises. All right, so I have a simple example coded up here. There might be some iteration of this in the coding example I gave to you guys, but here I want to do a few tasks. And unfortunately, these tasks rely on one another, so I can't fully do them asynchronously. And also, they take a fair amount of time. So just to go over the code I have here, I have a function called pour cereal. And this pour cereal, basically, imagine me pouring cereal. That's going to take 3 seconds. So I have a set timeout at the very bottom that calls pour cereal. And then it's going to take three seconds for me to pour that cereal into my bowl. So once I've poured that cereal, I'm going to print out, hey, we poured the cereal. And then I proceed to my next task, which is pouring milk. And I just want to take a little segue here. There's a right order to this. For those of you that pour milk before cereal, that's wrong. Sorry, I'm just going to say that. Cereal goes in first and then milk. I know there's a huge controversy. Some people say milk first and then cereal. No, it doesn't work that way. Sorry.
Smart man.
Sorry, I don't want to stir up controversy here, but I'm a serial first guy. I'll just say that. I won't say it's wrong. But yeah, so I pour my cereal in first. And then once I'm done with that, I actually proceed to pour my milk. So I have this pour milk function, which also takes 3 seconds. So again, I'm not that talented. I can't both pour the cereal and pour the milk at the same time. I got to pour my cereal first. And then once I'm done with that, I pick up the milk gallon and then pour my milk. So let's just say pouring milk also takes 3 seconds. So in that case, I set as timeout for my pour milk callback function, and that's going to take 3 seconds. So imagine me pouring milk, it takes 3 seconds. When I finish, my callback gets executed. So I'm going to print out, hey, we poured the milk. And then also now we can eat. Now that I have my cereal prepared, I can kind of go about doing that. All right, so this is an example of using nested callbacks. Again, the reason we had to do this is because both these tasks rely on one another. So the milk relies on the cereal being poured. So again, I could have this in like my larger application where I might execute this, call set timeouts, and then proceed to do something else. Like, again, me as a human, I can't pour cereal and like multitask that way. But if my application wanted to do other stuff while I was pouring the milk and pouring the cereal, then I could go do that. So that's kind of why I have these set timeouts to simulate that. All right, so let's actually make this, take this one step further. So just a little personal note about me. It's not the best, but I actually let my dishes pile up, and I kind of get to a state where I actually want to eat something and I need to wash some dishes because I don't always have clean dishes ready to go. So I kind of got to take that extra step. I know some people kind of wash the dish right after they use it. I wish I was that kind of person, but I kind of just get lazy after I eat something and I'm like, all right, I'll take care of it later. And then before I know it, like end of the week, my sink is piled up with tons of dishes. Probably more information than you need to know, but that's just kind of how I operate here. So let's say in this case, I actually need to wash a bowl and spoon before I actually can pour cereal because I don't have a clean bowl to use. So in this case, I have additional tasks that I've added to my code. In this case, I've called it wash dishes. And this is going to take approximately 15 seconds, so 1500 milliseconds, so 15 seconds to wash a bowl and spoon from my sink. All right, so there's a quick rinse, add some soap, and dry it off. So that's my wash dishes example or task. So once I complete that task, I go back to my previous example of pouring the cereal in, which takes 3 seconds, and then maybe pouring some milk, which takes another 3 seconds. So again, I added another task here and kind of notice how our code's looking here. Like we keep nesting stuff, and we have a nested callback within a nested callback within a nested. Sorry, we have a nested callback within a nested callback of a different callback. So in this case, this is 3 levels deep, kind of like Inception level, where you just keep going deeper. This actually has a term from coders, maybe not an official term, but it's actually known as something called callback hell. So you might hear of this. This is the notion of you're just going to have callbacks nested within callbacks. Again, these are 3 tasks that I'm doing. What if I had a task that had like 12 different components to it that relied on each other? I'm going to just be nesting callbacks within callbacks. Like this is going to get very deep and very nested. It's not the most elegant. It gets messy, kind of hard to kind of deal with. Okay, so that's the callback hell concept that you might hear about. So this definitely will work. It's just not the most elegant or easiest way to parse this code or design this code. All right, so this is where we get into the idea of JavaScript promises. So let's proceed. Just giving a definition, a dictionary definition. A promise is a declaration or assurance, a declaration or assurance that one will do a particular thing or that thing will happen. So as Josh said, something that's going to happen in the future, something that you guarantee will happen. So that's a definition of a promise. But let's actually talk about what a JavaScript promise is. So again, very similar to the idea of a promise. A JavaScript promise is a mechanism that promises to deliver a result. And the result may be a completion, as in you successfully did your task, or even a failure. So going back to our friend's example, in that case where Kyle maybe couldn't find the answer or the answer didn't exist, you might return an error saying, hey, actually, there's no answer to your question, or cannot locate the answer to your question. Or it might have been completion. He might have been said, all right, Chandler went to the store. He actually bought barley, which is not really a sensible food item to bring for a party. But yeah, so that's the eventual result that's going to come back to us of an asynchronous task. So gave a task, expecting a result. Result may be completion. I did it successfully, or it might be failure. But either way, I'm going to get a result back from the task that I assigned. All right, and as noted, it passes a value back upon completion. So I get a result back. In that case, I get a result of barley, or I might get a result saying, hey, answer not found. All right, so the calls are actually specified for a callback function. So there's a callback function for success. So if you got the correct answer or the answer that you're looking for, you could have a callback that will execute upon that answer. But also you can have a callback for a failure case. For example, if I get a response of, hey, answer not found, I might have some logic that I want to do like, hey, maybe I'll search for a different question or try to maybe use a different source, who knows. So you could have different callbacks based on success or failure. All right, so a lot of technical jargon there, but that's kind of the idea of JavaScript promise. Let's actually look at the syntax for creating a promise. And I will say right off the bat, I kind of struggle with this, just like it's not trivial kind of understand the whole syntax of promises, but hopefully it's clear enough when we get through this lecture. So here's an example of me creating a promise. So the syntax for this is I use the keyword new. This is a reserved keyword in JavaScript. And then I use capital P promise. So this is actually going to create a new promise object for me, or an instance of a promise. All right, so this promise actually takes in what you see in parentheses here. So it takes in a function as a parameter. So again, I'm using the fat arrow syntax to create a function on the spot, also known as an anonymous function or an inline function. I could create this function separately and then pass it in. But in this case, I'm going to use fat arrow syntax. And again, this is very common, so get used to it, please. Yeah, so this function the function that I pass in should take in two parameters. One is a return success callback, and one is a return failure callback function. So again, this function takes in two other functions as a parameter. So again, kind of a lot going on there functionally, I guess. But these parameters are actually functions. All right, they're callback functions. And then the body, this is a sample example. Like I might go do something asynchronously, whether it be looking up capital of Turkmenistan or doing something more complicated. Just imagine do something is actually doing something for us. All right, so that's going to return a result. Either a success, like, I got your answer, or maybe a failure, like, hey, couldn't find the answer, or application crash, whatever it may be. So let's say, if we get a success case, we're going to call the success callback function. All right, so in this case, the success callback function must take in one and only one parameter. So in this case, I'm passing a string, but I don't know how to pass in a string. This can be an object I return, and that's probably the more common case, because you don't want to pass multiple items of data, and the way to do that is to kind of nest it within an object and then pass that object back to your callback. Oops, sorry. So again, if I successfully do my task asynchronously, I'm going to call my success callback and pass it some value. In this case, it's a string that says successful task. Otherwise, let's say I fail. So in this case, success will be false. The if statement, if condition will be evaluated to false. So I go to my else statement. My else says we'll basically call the failure callback and then pass some other value to it. So in this case, I'm just passing a string. Again, this could be anything that I pass back. In this case, I pass a string that says, hey, there was an error with some exclamation marks because that was a problem. All right, so again, this is a syntax of creating a promise. You use new, then promise, capital P. You got to pass it a function. The function must take in two parameters, and those two parameters are callback functions themselves. So it's functions within functions, sort of. That function takes in two parameters, and those parameters are a return callback for success and a return failure callback on failure. Then you do your logic and then call the correct callback based on the result of your task. All right, any questions there? I know that was a lot. This is, it's not easy to understand. So any general questions there? All right, sounds like we can proceed. All right, so let's go continue on with our example, consuming a promise. So line 1 here is the same code that I had before. It's this promise I'm creating. The ... is all this logic here. So again, I create my promise on this line. Then I actually consume my promise. So this is where the .then syntax comes in. So we'll talk about this shortly. But I'm going to create a couple event handlers. So in this case, these handlers, not event handlers, but callbacks, will take in a message because I'm passing a string for my promise. So I'm going to take a string, basically print out that string out to console. So in the success case, I'm going to say be happy and then print out my message that I got back from my asynchronous task. Or in the failure case, I'm going to do something similar. I'm going to print out be angry and then pass the value I got back from my asynchronous task. All right, and then so the magic, or I guess the key point, is at the very bottom. We have my promise, and then this method called .then. This is key to using promises. So this .then will execute once this promise resolves. So initially, when this promise executes, again, it might take 5 seconds, might take 20 seconds. We don't know how long it's going to take. But eventually, when it does return, because it's promised that it's going to return some value, either on success or on failure, once that happens, the .then gets invoked. So you might see this and think like, okay, the .then is going to happen right away, but that's actually not true. So .then only executes once your asynchronous task has completed, as in has a result for to deliver. All right, I get my tongue tied here. Sorry. The .then takes in can take in 2 handlers, so one for success and one for failure. So I kind of color coded this. So again, we go back to this example. We called a callback on success or a callback on failure. So that's actually how these are kind of tied together. So the return will pass back a value. Again, be one parameter. That parameter in this case is a string. So MSG or message is a parameter. So this handler should expect to take in 1 parameter and then use that parameter however it wants to. So again, if I have a success case, I get a string because my promise returns a string in this case. I take that string and do what I want with it. Likewise, if I had a failure, so return failure callback got called, it's going to pass also a string. Again, this doesn't have to be a string. It could be anything you want. You just got to understand what you're going to get back. In this case, return failure is going to pass back a string. So my handle failure should be prepared to take in a string and then use that string however it wants to. So the .then executes only when your asynchronous code completes. All right, so I have this coded up also in our code. So let's actually, I think I have it in my code. I have a serial example. Yep, okay, so let me bring up my coding window. I'm going to uncomment this section for promise example. Actually, yeah, let me go back a step. Since I didn't do my serial example, I'm just going to want to do that since I have that here. Uncomment this. So I have my serial example, and we could actually see this in play. Let me bring up my terminal. All right, so again, we went over this. We just have nested callbacks here. So just to show that it can work, I run this. We're going to pour our milk. It's going to take 3 seconds. And then, all right, we poured our milk. And then we're going to, sorry, we poured our cereal. And then we pour our milk, which takes another 3 seconds. And so that's the delays you saw there. And then we can eat once both those tasks are done. All right, so that was a quick example. Let's go to the next example in our code. This is the promises example. So I'm going to uncomment that block and kind of see how that works. All right, so I have my task here, which is kind of just a simulated task. But in this case, my promise is going to execute this asynchronously. And then once it's completed that task, it'll call my it'll call the return callbacks, and those will execute in the .then. All right, so let's actually see this. Let's actually talk about the code. So in this case, my success case is just totally random. And in this case, I'm going to succeed with whatever my task is 70% of the time. So basically, if my random value is greater than 30.3, so random is going to be a value between 0 and 1, a floating point number. So in this case, I'm going to expect to succeed around 70% of the time when I execute this promise. However, 30% of the time, I'm going to fail my task. And this task can be whatever you can imagine. But in this case, it's going to call my return failure, and that's going to call a different callback. So I call return failure, which is handled by handle failure, and I print out be angry in the case that I fail, or be happy in the message if I succeed. All right, so this is just trying to give you an example of the syntax and how it kind of works. So the return success is what you want to call when you're successful, and that will be handled in one way. And then if you have a failure, you can opt to handle that in a different way. All right, so let me run this block of code and kind of see what happens. I'm going to run it a few times because I kind of have this random in here. So let's call that. Okay, so I ran it one time. Again, there's no delay here, so it's going to execute right away. I could simulate it with a set timeout if I wanted to actually have a delay. In this case, I was just interested in the concept of a promise. So in this case, I got be happy, successful task. Let's actually run this a few times. All right, so successful. Oop, I got a couple angries here. So this evaluated to false, as in I did not succeed whatever my task was. In that case, my failure callback got called. And then I got the printout of be angry, there was an error. All right, hopefully you guys don't get angry when you actually encounter errors. It's part of software development, debugging, and whatever it may be. But yeah, so again, simple example of using a promise. Again, just want to highlight my code. You create a promise with new promise, pass it a couple of callbacks. These callbacks you call based on whatever criteria you have for success. And then again, this is we have the criteria here, but usually you're going to pass a promise to someone else. So like I might give a promise to Brian, for example. He's going to take that promise and then do the task and then use one of my callbacks. If he found the answer, he's going to say return success. I found the answer. It's Susan died because she was looking at text envelopes. Or if he was unable to find an answer, like maybe the answer does not exist, or he just couldn't find it, he might be like, all right, return failure, I couldn't find your answer. So that's how the success is kind of done. Third party is kind of determining that your success. You're not the one necessarily determining the success there, because everything in here is done asynchronously. So someone else likely is doing this task over here, but they know that they can call a callback. That's the reason we have the concept of a promise. It's a standardized way where whoever you give the promise to knows that, hey, if I succeed, I could tell you one way. If I fail, I could tell you in another way. All right. All right. So again, that's a very simple promise example. Just want to be familiar with the syntax and kind of understand kind of what a promise is doing and why it's used. All right. So let's actually go back to my slides. All right. Let's go back to our serial example. So serial, I'm a huge serial enthusiast. So let's actually change this to use promises instead of using callback. Again, callback hell, which we talked about, can kind of get messy. Promises just make your code a little bit simpler to read and understand, but they both effectively are doing the same thing. All right, so I have a few functions that I'm creating. In this case, I have a go hungry, which is, I guess, my error case. It's going to be I'm still hungry. Then I have my tasks. I have wash dishes, I have pour cereal and pour milk, and the ... is actually the code that I had before. So, I'm usually printing out a statement and then waiting like 3 seconds, like setting a timeout. So that's what you can imagine what's the ... I just didn't have space to kind of write it here. All right, so notice that this function returns a promise, and we're going to talk about why that matters. But we're returning a new promise from within these functions, and that's going to take in a resolve and reject handler or callback. And yeah, so each one of these returns a new promise. And yeah, then we could use it. So when we call wash dishes with parentheses, that's going to invoke this function. So it's going to return a promise for us. And then we call a then on it. So again, once wash dishes is actually done with this task, which is going to be in this ... section that I didn't type. Once that task is done, it's going to call the then for wash dishes. So then will get access. So in this case, we have two handlers. One, the success case is we're going to proceed to pour cereal once our bowl and spoon are washed. Or if we failed to wash a dish, like something went wrong, either we're out of water or we broke our dish. I don't know, whatever can go wrong when you're washing dishes. If we get an error case from washing dishes, we're going to go to our go hungry handler. In this case, I'm just going to say I'm still hungry because I didn't get to eat my cereal. All right, so again, the then only executes once wash dishes, once that promise has resolved within it. All right. If we look at our pour cereal handler, that's what I have here, we return a promise from that. Again, so this is the idea of chaining promises. So, wash dishes, guarantee that it's going to give us a result. Once wash dishes is complete, on success, we're going to proceed to pour cereal. Pour cereal is also another task that's going to be asynchronous. So I'm going to do my pour cereal action again. The ... is going to be the, whatever, the 3 seconds of pouring cereal. And once I'm done with that, that's another promise that I'm completing. And so it's going to call the then on that promise. So this line over here, the then for the pour cereal, is another promise because that's what I'm returning from my function. So I could actually chain another then onto that saying, hey, when you finish your promise over here, proceed to pour milk. So do the next line here. So the pour cereal, once that succeeds, we'll call pour milk. And then we look at pour milk. That's yet again another new promise that we're creating that has resolve and reject handler or callback, and then the ... is the task we need to do asynchronously. So that will complete, and once that completes, we call a function. This is not a promise. We just call a function called eat breakfast, which is going to say, hey, we pour the milk, and then we could eat our cereal or whatever it may be. Okay, so again, I didn't code write all the code up here, but I do have a coding example in the code file that's applied. So let me comment this. Again, the shortcut would be command / to get rid of that and comment it. Then I have this last section, which is a bit longer, but we can kind of talk about it. All right, build there, shift, and come. All right, there we go. So I have this block of code. So it's similar to what I had on screen, but I have a bunch of functions. So I have go hungry, which will take in an error. It's a little different than what I had on the slides, and print out that error, and then print out I'm still hungry. I have my wash dishes, my pour cereal, and pour milk. Again, you know, hopefully this will be familiar. We went over this example. I do have some added logic in my pour milk. I have a spill case. So I'd say 5% of the time, maybe I spill milk, and then I, you know, can no longer have my cereal because, I don't know, maybe I spilled all the milk and I have no milk left. I don't know. All right, so there's a 5% chance that pour milk will fail, as in I spill the milk or whatever it may be, and that's gonna be a reject condition. So if spill is true, then we're gonna call a reject callback with the notion of, or the string of, we spilled some milk, all right? Otherwise, on the typical case where we succeed, we're just gonna return, hey, we poured some milk. That's our you know, result of this operation. All right, so notice at the very bottom, I have a bunch of chained promises. So I create my promise for wash dishes. Again, I don't actually have to assign this to a variable. I could simply do something like this without this variable here. All right, so I can do wash dishes. That's gonna execute a promise. Once that promise completes, it's gonna call dot then. And then once that promise completes, it's gonna call dot then for that promise on line 111. Once the promise on line 112 completes, I'm gonna call another promise and resolve it with dot then. Notice the syntax here is a little different than what I showed before. So let's actually go back to my slides. So one way to do this is I could have a dot then that can handle the success case and a failure case. In this case, my failure case is always go hungry. If I fail to wash my dishes or fail to pour my cereal or fail to pour my milk, I'm just gonna go hungry. Like apparently I can't recover from messing any one of those things up. So in this case, my go hungry case is the same. So instead of always having a handler for the failure case for each dot then, I kind of just collapse it down to a catch. So sorry, that's blocking what we want to see there. All right, so I have a catch at the very bottom. That's going to keep popping up, isn't it? Yeah, so I have a dot then, and then finally a catch. So if any one of these promises fails, the dot catch is going to capture that and then execute the go hungry handler for it. So again, instead of having each dot then have a failure case, I just use dot catch. So if any one of these promises fails, I'm going to go to my go hungry handler and handle it that way. So that's what I have coded up here. So again, anything fails, I go hungry, whether it be pouring cereal, pouring milk, or washing dishes even. All right, so that's
Question, Encore.
Yep, go for it.
How come you don't have to put parentheses when you call pour cereal function or any of the other functions?
Good question, good question. So pour cereal, if I look at the definition of pour cereal, it gets invoked when the callback is called. So when I call resolve, it's going to take this parameter and pass that to a function. So I don't want to actually execute the function here. If I put parentheses here, this is going to execute this function right away, but I don't have any value that goes here, right? So instead, I have my function defined that it takes in a parameter, and that will get called when I call resolve. So when I call resolve, we poured some milk, for example, that'll pass the result here, and then it'll actually call that function for me. So yeah, I don't actually manually have to call it here. The dot then will kind of take care of that for me.
Okay. And then on line 97, is that return necessary?
It is necessary because if I call reject, it'll proceed to also call resolve. So in this case, when I call reject, I don't want to also pass it a resolve case. And we could see this, like, you know, maybe I could be mistaken, but yeah, this return is needed because we want to reject and stop our operation. We don't want to, you know, we might have some additional logic here, like additional tasks, right? If we didn't spill milk, maybe we want to grab a spoon or whatever it may be. So we don't want to do those additional tasks if we have reject. So I don't think reject is going to automatically end our tasks here. So I'm pretty sure we need that return here, but we could definitely check that.
Would that be the same as just doing an else and then resolve we poured some milk.
Yep, absolutely. We could do this.
Oh.
Another way to handle it. So I could do that, and this would alleviate my need to have a return.
Okay. Okay, thank you.
Good questions. Yep. Keep asking a question again. Anyone else has questions? Again, I'm throwing a lot of code here. So if you guys definitely have any questions about what I have or any concepts that we're going over, obviously that's the benefit of a live lecture. All right. So again, that's the syntax. Again, it's not an easy concept, at least not for me. So it might take some practice and kind of just, reading documentation, kind of understand promises more in detail, but just understand kind of what promises offer and kind of how you use them. All right. Excuse me. Last thing I want to talk about are promise states. So when you create a promise initially, again, these are asynchronous tasks. So the initial state will be pending, as in, hey, I'm still doing some work, so there's no result I have for you. But eventually you'll get either a fulfilled, meaning your task was successful, or a rejected state. So actually, let's kind of investigate this to see it in play. I'm going to actually increase my chances of spilling milk from 5% to, let's say, 80% of the time, I'm going to spill my milk, which is not very smart of me, but let's go with that. So I'm going to bring up my terminal here. All right, there it is. And then I'm going to run my code. So that's node async. All right, so we're going to see some input. So again, it's going to take, I lowered my washing dishes to 5 seconds. I don't want to wait 15 seconds. So I washed the bowl and spoon, great. It's going to take 3 seconds to pour milk. Now, do we spill milk? Yep, we spilled some milk. So we went to our is hungry or still hungry handler. We spilled some milk, I'm still hungry, was the error case. So if I go back to go hungry, that takes in an error, which is a string, and then prints out this message that we want. All right, so that was an error case. If we want to just make this more likely that we succeed, let's make that 10% chance that we only spill. We'll run that. Let's actually investigate something. So I'm gonna let this complete. Wash the bowl and spoon, sure. All right, we poured milk, and now we can eat. So that was a success case. I'm actually going to run this through my Visual VS Code debugger, so we can actually investigate some things of interest. Undo some stuff here. All right, so we have this promise wash dishes. I'm going to actually just add that here as my final case. But let's actually investigate promise wash dishes. To kind of see what values it's holding. So let me add a breakpoint on line 111 and a breakpoint on line 107. All right, so I'm going to go to my run, go to debug, and then launch it in Node. All right, it's going to start executing, and hopefully it will break. All right, so we have a breakpoint. It got hit on 111. So let's actually go to my debug window, which is the 4th item on your left panel. Looks like a little triangle and a bug there. So here I could investigate some values. So I'm actually going to scan this out. Hopefully it's not too small to read. I don't know if I can boost it a bit. All right. So here I'm going to find this promise wash dishes, which is a variable I created. And notice this is a promise. So that's the object type. And the state is pending. So if you can see here, the current state is pending because the promise hasn't resolved yet. We actually broke our code as in we're stopped. So the promise is still pending. Let's actually continue. So I'm going to minimize window. It's kind of gigantic. I'm going to proceed. So I hit the play button. All right, it's going to do some tests. Let's look at our output. We washed a bowl and spoon, poured some cereal. Hopefully pour milk. Yep, we didn't spill. And then we hit our breakpoint on 107. So let's actually look at our promise wash dishes now. So we look at our status, and it says resolved. So again, the status changed because our task got completed. And we have a value also. The value is what we returned from our promise. So we have status is resolved, and we washed a bowl and spoon. All right, so those are just states that your promise can have. They're not usually too helpful, as in like you rely on the callback that's called. You don't really need to investigate the state, but just know that there are 3 states that a promise can have. All right, that covers promises. Let's take a break. I know we've been going probably for an hour, so let me stop the recording here.